Thank you for joining our webinar. My name is Brett Bergdorf, and I'll be hosting our presentation. Joining me for the presentation is Madeline McNabb, our Director of Business Development, and Chad Dillard, the Manager for Direct Sales in North America. Today, we'll be reviewing our TrueView line of LiDAR and imagery sensors and introducing a new Riegl-based survey-grade sensor. For today's presentation, Madeline will start things off with a brief review of our history. Then she'll go over some of our new and exciting developments and projects. Next, we'll turn things over to Chad to go through an overview of our TrueView product line. Then we'll conclude with a business discussion by Madeline, reviewing our pricing and what's included. Should you have any questions today, please use the GoToWebinar chat toolbar on the left-hand side of the screen, and we'll have a response for you within 24 hours of this presentation. Now I'd like to introduce Madeline McNabb to get things started. Welcome, Madeline.
Thanks, Brett, for the intro. Well, I must say it's been a while since we've hopped on a webinar to discuss the TrueView product line. Today's presentation, as Brett said, will focus specifically on our line of sensors, how to understand system specification, what's included, and what's the cost. So before we begin discussing the technology, just a bit on GeoQ's history. GeoQ was founded in 2003 with an initial focus on kinematic LiDAR software products. At that time, the aim was the manned LiDAR market. In 2009, GeoQ acquired LP360 software, a product we actively sell, develop, and support today. In fact, it's at the core of our TrueView product line. In 2014, GeoQ began actively pursuing and developing products aimed at the drone market. In 2019, we married our experience and technology with the release of our TrueView 3D imaging systems. The LiDAR camera and software package we'll be discussing today. At the beginning of this year, GeoQ was acquired by MD Group, the parent company of Microdrones. The combination of these two companies is already reflected positively in the rapid advancements of our technology, both on the hardware and software side. You'll see a few of these through our discussion today. So what's new? I first would like to address a few items for our existing customers and followers. We recently rebranded TrueView Evo to LP360 Drone. This is simply a branding change, no licensing updates. Additionally, you'll notice as I continue talking that strip-align for Evo is now strip-align and Metashape for Evo is LP360 Photo. So now I'll start talking about our lineup of sensors. This includes the TrueView 435 and 515, which are both based on the Pandar XT, and our newest sensors, the TrueView 655 and 660, based on the Riegl MiniBux 3. If you're familiar with the TrueView systems, you know all systems include tightly integrated cameras to allow for direct colorization of the point cloud. Our newly released 655 and 660 add a third nadir camera, allowing users to collect the imagery from dual obliques as well as the nadir view. All systems are light enough to mount to the DJI M300. When customers acquire a TrueView system, we include extensive software for processing to a final deliverable. Embedded in LP360 Drone, users can generate orthos or apply geometric corrections. We also have product generation tools like contours classification, exporting DIMMs, and volumetrics. One especially and exciting new feature, building on our previous tools for extracting power lines, we just released our vegetation management tools, allowing users to analyze problem areas around power lines with ease. When it comes to delivering data to clients or internal data consumers, GeoQ offers a license for visualization, a nice tool for users who need to see data but not work with it. This license also includes our Image Explorer tool, allowing the users to click a point in the point cloud and zoom to the camera images associated. Great for quick inspection. Every month, GeoQ conducts on-site training at our facility in Madison, Alabama. We cover mission planning through product generation. This training is also available virtually. We've tried really hard to include all aspects to make the user implementation seamless. So now I'm going to hand the presentation over to Chad for an overview of the system specifications and comparison.
Thank you, Madeline. So today I want to talk about our product line and kind of the sensors that we offer. So on the screen, you'll see our TrueView 435. That's what we consider to be our entry-level sensor. And then in the middle, we have our TrueView 515. That's our mid-level sensor. And then on the right, you'll see our new TrueView 655 and TrueView 660. We consider these to be our high-end specialty sensors. So first, what is a 3D imaging system? So a 3D imaging system, or 3DIS, as you'll often see us referenced in our documentation, is a fully integrated LiDAR plus camera mapping system. So the LiDAR sensor and the camera are integrated together. They're both calibrated to the position orientation system, so we know precisely where the cameras are looking, and we know their position. So doing that, we're able to colorize a point cloud in a little more intelligent way. So what you're looking at on the screen, we've got two screenshots, one on the left. This is our building here. This point cloud was colorized from an orthomosaic in kind of the traditional manner where you take an orthomosaic, you overlay a point cloud on top of that, and then you assign colors to the points based on the color in the orthomosaic. The downside there is that you only have one RGB value in any XY location. On the right-hand side, we have our point cloud colorized. This is a point cloud from a TrueView 3DIS. This colorized with an LP360 drone. And you'll notice some differences in the two point clouds. Notice the trim along the top of the building. You can see the red trim. On the image on the left, you don't have that. And then down kind of on the left there, we have a garage door. On either side of that is two red doors. You can see those colorized. You don't see those in the image on the left, and that's because it doesn't have that oblique view with the cameras to colorize those objects. So colorization is obviously one advantage of having a 3DIS with the dual oblique cameras. But colorization is not even the biggest advantage of a 3DIS. So the true advantage of a 3DIS is efficiency. So with the 3DIS, you're able to really maximize your flight coverage area. And so this two diagrams we have on the screen kind of highlight why that is. So on the left side, the diagram on the left, this is what a LiDAR with a single camera integration would look like. So the LiDAR scanner itself can collect, we configure them to collect out to 120 degrees. And so a single camera system is not going to be able to match that field of view unless it's an ultra wide angle lens or a fisheye lens. And those types of cameras aren't really ideal for metric mapping because they're so wide, a lot of distortion in those lenses. So if you're trying to build an orthomosaic from a single camera integration, you have to plan enough overlap on the images to be able to get the orthomosaic, so that you got overlapping images and are able to build the orthomosaic. So you're squeezing your flight lines in, you're going to have more flight lines, which means longer flying time. So on the right, the diagram on the right, we have a TrueView 3DIS integration. And so as you can see, the two oblique camera fields of view are designed to match the LiDAR field of view. And in addition to that, you even have an area in the middle where they overlap. So the two cameras do overlap some in the middle, and they match the LiDAR field of view. So what this lets us do is plan our mission based on the efficiency of the LiDAR, or the swath of the LiDAR. And so then we can spread the flight lines out and then collect, map a bigger area in the same amount of time. And then also the diagram on the right shows with the addition of the third nadir camera on the TrueView 655 and 660. So this is a good representation of why you would want a 3DIS with the dual oblique cameras if you're really trying to maximize flight time and coverage. So let's talk about some of the specs. So you'll often see us, we'll reference a LiDAR usable range. So we're not talking about max range. Both of these sensors, all these sensors can collect data beyond what we consider the usable range, but this is more of a safe number to use so that you don't end up with dropouts in your point cloud. So it's not to say that you can't collect data beyond this range. You can. In fact, we've done it. It's just that if you're looking for a good safe number, to make sure that you're getting project coverage and you don't have dropouts, we recommend sticking to the usable range. So for the 435 and 515, I'll go ahead and mention that these two platforms are built on the Pandar XT sensor. It's an automotive grade LiDAR sensor. So we say these two sensors have a usable range of 80 meters. And then on the right side of our chart here, you can see the TrueView 655 and 660. We advertise a LiDAR usable range of 100 meters. Now the sensor has a much longer range than that, but once you start getting to a certain percentage of reflectivity, you start getting darker surfaces, you'll start having dropouts and stuff, and then it could impact the results. We say that the sensor has a usable range of 100 meters, quite a bit more range on the Riegl sensor. That's what the TrueView 655 and 660 were integrated on the Riegl MiniVux 3. So obviously you're going to have a much better range on that sensor. Okay, so let's talk about sensor returns. So when the LiDAR sensor, the way that it operates, it emits a pulse of light and then hits an object, and then the energy is reflected back to the sensor, and we call that a return or an echo. And that's how the range is calculated, based on the return, the amount of time it takes for that pulse to travel to the object and back to the sensor. If enough energy remains after that, a second return can be detected. So I can get a return value from, let's say, in this diagram, the pulse of light strikes a tree branch. I know the range, and I could plot a point based on the return value that I get from that tree branch. And then if I have enough energy to continue, if the pulse has enough energy to continue and strikes another branch, I get a second return. And then third branch, I get a third return, and so on. And eventually I strike the ground, and I can get no more returns beyond the ground. So, a measure of quality of a sensor is the number of returns. Obviously, the higher quality sensor is going to be able to produce more returns, and whether that means for your data collection, that means you're going to be able to get more points on the ground through the canopy, because you're able to get more points beyond those initial first one or two returns. So our TrueView 435 and 515, both are two return sensors. The difference between these two sensors is just the number of beams, or the number of channels that they have. So the 435 has 16 channels, or 16 beams, with 2 returns per beam. The 515 is just double that, the 32 beams, 2 returns per beam. And then on the Riegl MiniVux 3, the 600 series TrueView systems, they have 1 beam up to 5 returns. So that's where you're going to see this sensor separate from the others. You're getting more returns, deeper penetration through the canopy. So for vertical accuracy, so LP360 drone has a tool to measure vertical accuracy, which I think is very valuable. If you're going to be delivering products, you need a tool to compare your point cloud to your checkpoints. And so all the numbers that you're about to see were done in LP360 drone. So we did a test flight here at our site at 75 meters, and then we take 30 checkpoints. We do no geometric corrections, and we include all the flight lines. And these are also done on hard surface. So if you're trying to gauge what LiDAR accuracy is compared to, say, photogrammetry, this is the best way to do that, because your photogrammetry, you're not going to get returns in vegetation. So the only way to compare it is on hard surface. So we did this to give photogrammetry equal footing there. So for the 435, like I said, the previous slide, we showed the accuracy that we advertise of 5 centimeters on the 435 and the 515. And then for the 655, we advertise a 2.5 centimeter, 3 centimeters of accuracy, and then for the 660, 2.5 centimeters. So we like to be conservative with the numbers that we're advertising, but we often are able to exceed that, as we see here. So this is a check against our checkpoints. So for the 435 and the 515, we're able to get 3.2 centimeters of root mean square at 75 meters. And then for the 655 and 660, we were able to get 1.6 centimeters, and that's compared to the checkpoints. Okay, so another, when we're talking about precision, it's basically the repeatability of the scanner. So if you were to fire a pulse of light, fire your laser at a wall or some object that's a fixed distance, the distance between the sensor and the object doesn't change, what would be the difference in the measurements? Even though the distance doesn't change, how often can I repeat the same measurement? That's essentially what your precision is. So we have a tool in LP360 Drone to measure this as well, called the planar statistics point cloud task. And so we're going to show you some of the numbers, some of the metrics of these sensors. So these screenshots, these are just profiles. These are we have a tool where we can draw a cross section of your point cloud. So you're basically looking at the point cloud from the side view. The grid squares that you see on the screen, those are 10 centimeter grids, or 0.3 feet. And so we're seeing the overall precision level. Oftentimes you'll hear people call it the noise. So the kind of the thickness of that point cloud. So the thickness in this section, this is on a stretch of sidewalk here at the office. That's a hard flat surface. So it's looking, I'm seeing, looks like 8 centimeters there of overall noise. But when we measure precision, we're measuring the distance at 1 sigma, or 1 standard deviation. So so for the 435 and the 515, we're seeing 3.4 centimeters at 1 sigma. If notice too that at the 435 and the 515, I don't see a decrease in the precision level. I just see more points. So which is what we expect. It's essentially the same sensor, just fewer channels. But a lot of times in a lot of sensors, you'll see a decrease in the precision level when you increase the number of points, and you don't really see that here. It's able to maintain a similar level of precision despite doubling the points. So it's pretty impressive. And then of course at the bottom we see the Riegl based sensors, the 655 and 660, and notice how thin that is. It's extremely thin, especially compared to the other 2 sensors. So precision at 1 sigma is 1.6 centimeters, point density 178 points per square meter. So despite only having 1 beam, we're almost matching the point density, and the precision level is just a lot better. So pulse repetition rate. So when we're talking about pulse repetition rate, we're just talking about the rate at which it can collect points. So 320 kilohertz means 320,000 points per second. So the 515 and the 435, again, these are same basic sensor, but just half the number of beams. So the numbers we see here, what we expect: 320 kilohertz for the 435, 640 kilohertz for the 515, and then for the 600 series, 300 kilohertz selectable. All right, so that's all for the technical discussion. So I'll hand it back over to Madeline.
Thanks, Chad. So now I'll dive into, of course, the important part. What's it going to cost? So I'll start with, so you'll notice as I'm going through, we have several different business options. So I'll start with our lowest cost option, which is our rental. So we offer monthly and extended rentals on both the 435 and 515. So the 435 rental for 1 month starts at just under $7,000, and the TrueView 515 starts at just under $8,000. When you rent from GeoQ, it includes the hardware, including the mounting kit for the M300 or M600, as well as a post-processing software, training, and support for the duration of the rental period. Our next option is the pay-as-you-go on the 435. So the reason for this option was to give users a low-cost entry point, but limited flying time. So at $45,000, that's the purchase price. It gives you 40 kinematic minutes of processing time each month. Our next option is the purchase traditional model for the 435, which is priced at $60,000. So this includes the hardware, software, training, and support. And new to this, we include a license of strip-align as well as desktop photo. So you'll be able to process your orthos as well as do geometric correction with the 435 traditional. Our next option is the traditional 515, which is priced at $75,000. Just like the traditional 435, this includes the hardware, software, training, and support. And then, of course, our latest and greatest, the TrueView 655, 660. So I'll talk a little bit about the difference there. So our 655, which is priced at $174,000, is integrated with the Aplanix APX 15 IMU, whereas the TrueView 660 is integrated with the APX 20 IMU. So the TrueView 660 is priced quite a bit higher than the 655 at $209,000. Again, with the 655, 660, an upgrade from our previous model by adding that third nadir camera. So we're really excited about that. So if you've been following along with the TrueView platform for a while, you know that we're a payload provider. So in terms of the drone platform, we're agnostic. As long as the sensor can mount to the payload and it can carry the payload weight, the landing gear does not obstruct the view of the sensors, then we can in theory mount to any drone platform that's out there. So to give you an idea of some of the providers that we've integrated with, of course, DJI is pretty popular here in the States. But also we have a lot of options outside of DJI, FreeFly here, Skyfront, Inspired Flight, and of course our sister company, Microdrones. Other considerations, so with all systems, it is our recommendation that you have a base rover kit. If you only have a base system, that's fine. You'll just want to make sure that it's L1, L2, and has the ability to export a Rhinex file. And finally, talking about our no worries support and maintenance. So GeoQ values customers and ongoing support is critical to our customer success. All purchased systems include 1 year of hardware and software maintenance. All systems are calibrated prior to shipment, and if the system requires a recalibration, we do not require the system be shipped back to our facility. You simply upload a flight to the Reckon portal, our team will recalibrate it and post the results back. After the first year, customers can continue to cover hardware and receive system updates through our comprehensive maintenance packages. In addition to supporting our own sensor line, LP360 has tools specific to the DJI P4RTK, P1, and L1. These low-cost, entry-level systems are a great way to start and later grow into a higher performance TrueView system without needing to change your software workflows. LP360 can also ingest any LAS files. Our software can be used for generating products from any airborne or drone sensor on the market today. In summary, this is the start to a hefty agenda of new developments from GeoQ. The TrueView 655 and 660 build on the importance of collecting quality imagery simultaneous to the LiDAR. The new vegetation encroachment tools are powerful, and users benefit from having a single tool to address many different applications. GeoQ's customer base is diverse. We range from small survey and engineering firms to numerous government agencies. We're a nearly 20-year-old firm with extensive experience on supporting our customers' needs. Our aim as a provider is to be a single stop for implementing drone LiDAR into your business. We achieve this by delivering hardware, software, and training from one vendor. Thanks so much.
Thank you very much, Madeline and Chad. This will conclude our presentation for today. It's been our pleasure to meet with you and review the TrueView product line. If you have any questions or would like more information on anything you've heard about today, please contact us at info@goq.com. That's info@goq.com. Thank you very much, and we look forward to working with you.